So basically, wastewater standards falls under the environmental quality sewage regulations, which was confirmed in 2009. Okay, and these standards are put or are set up for the new sewage treatment and also the existing sewage treatment, which means that in 2009 they put, or the government in Malaysia put two kinds of standards, okay, or two tables or two schemes. Scheme number one is for the sewage treatment which will be built and will be set up, and scheme number two is for the sewage treatment that is already existed. Okay. Okay. And basically we have two types of standards. We have standard A and standard B. Why they make standard A and standard B? It is like any product. It's like any production line. Okay. Sometimes for the same product you will have high quality, high class, and low class. Class A and class B. Okay. So class A is a perfect one. Is 99% perfect. Standard B is like 85% quality, okay, something like that. So that's also in wastewater treatment. We cannot force all wastewater to be following standard A, which is the most perfect or the highest quality of treatment. Some kind of wastewater, it can be a little bit low quality because it depends on the place that it will be discharged to, right? So whether it is standard A or standard B, it depends on the location that the wastewater will be discharged to. Okay. So we have at the top of the pyramid is the Environmental Quality Act that was in 1974. Okay. After that came the environmental quality for the sewage, the regulations for the sewage in 2009. So from this regulation we have regulation number 7. It is talking about the acceptable conditions of sewage discharge of standards A and B. Now we will have a look about these standards A and B. Let's have a look here. So if you can see that for each parameter here we have parameter that like the temperature, the pH, the BOD, the COD. Okay, so here are the condition or the regulation for discharge of wastewater following standard A and following standard B. Okay, you can see that, for example, for BOD, following standard A, the BOD has to be 20 milligram per liter, but for standard B it can go up to 50. Okay, so that's you can notice that standard B is lower quality. It depends on the place that it's going to be discharged. Same goes for COD. Okay, same goes for COD. Now COD for standard A is 120, while for standard B is 200. So that makes standard A higher quality and standard B lower quality. Same goes to the suspended solids, oil and grease, ammonium nitrogen. Okay, ammonium nitrogen, if it's going to be discharged in the river, it's different from any water body. Okay, like the lakes. Okay, closed lakes. Nitrates. Same goes to the phosphorus. All these parameters have a value for standard A and value for standard B. Right. So the previous one was for the new sewage treatment plants. Now this is for the existing sewage treatment plants and any treatment plant approved after 1999. Okay, so any plant before 1999 and is going to be approved after that. Okay, it has to follow these standards as well. It's almost the same, but with some changes, okay, with some little bit differences. Same goes for BOD, COD, solids, oil and grease, ammoniacal nitrogen, okay. So we have standard A and we have standard B, okay. And here it is. Standard A is applicable to discharge into any inland waters within catchment areas listed in the third schedule, while standard B is applicable to any other inland waters in Malaysian waters, okay. So standard A is for strict areas, okay, listed in third schedule. It means that these are strict areas like environmental conservation areas, okay. I mean natural conservation natural conservation areas. These are restricted areas, restricted usage, okay. We need to save it from any pollution. We need to protect it from any human use or human pollution, so that's why the standard A has to be followed strictly. While for other waters like running rivers, open sea, open oceans, those can be following standard B without any problem. All right. If you have any question, just put it in the chat. So we continue here. Also are some these are standards for the parameters, but for each unit inside the treatment plant, okay. Now the treatment plant is not only one unit, as you know, and also we will take into we will discuss in detail after that, okay. So for each unit, the regulation put the standard of BOD, COD, suspended solid, etc. Okay, like for the communal or septic tank, this comes in the beginning, okay, and the Imhoff tank also come after that. The aerated lagoon come in the secondary stage, okay. So if following standard A, how much BOD should be reduced? It should be reduced to 100 after the aerated lagoon, okay. If we use oxidation pond, so the BOD has to follow or has to be 120, and so on, okay. So these are the standards for each unit or for some units inside the wastewater treatment plant, okay. We may not be able to go into detail for each unit now, because each unit has to take one class by itself, but we just should know that the treatment or the standards also put regulations for each unit inside the treatment plant, okay. Now this is an example, and now we will show a real example inside or around UTM that shows the treatment plant and where is standard A is discharged and where standard B is discharged. Okay, here is UTM. You can see in the top at the left, here's McDonald's, okay, you know the Petronas and McDonald's here, and here we got water treatment plant or water intake point, which means that SAJ is Sumbur Air Johor, so this point will refer to the point of intake, okay, understand. So this is the point of intake, which means that from this point there will be a collection from the river, okay, I think there's a river here, so from the river there will be a collection and then a treatment and then distribution to the people of normal water, okay. And from UTM we have a wastewater treatment plant, a small plant, so it will discharge wastewater. So now we will see how they combine together. This is a more close photo, okay. And now you can see this line is drawn here. So this line is a discharge or a wastewater discharge line. Now This is a wastewater treatment plant. As you can see here, you can see at the left side of the screen. Okay, so this is a wastewater treatment plant. All right, here, wastewater treatment plant at the left side, and here is the discharge line. After treatment, wastewater will be discharged through this line, crossing the main road and then to the river. Okay, to cross the main road and then to the river. This river, okay, this is a river here, is running from up to down. Okay, from up to down. Okay, the wastewater is discharged here. Okay, so this is the direction of discharging wastewater. This is the direction of running of the river. Okay, now here is the discharge point and here is the intake point. Okay, so this is the intake point. Intake means that the point of collecting water and distributing to the people. Okay, so the intake point came in the upstream and the discharge point came in the downstream, which means that the intake point, okay, moving with the river, intake point came before the discharge point. Okay, so that is what does it mean. It means that intake point came before the discharge point. Okay, any question until now? Okay, I hope everyone can understand and there is no any problem. Okay, all right. So this is the intake point and this is the discharge point, as we can see here. Now this wastewater treatment plant can discharge or can follow the standard B. Can follow standard B. Why? Because it came before the intake point. Imagine that the discharge is somewhere here, up. Okay, so in that case we say that it has to follow standard A. Okay, because it came in the upstream. But because the discharge point came in the downstream, which means that it's not affecting the intake point. Okay, it's not interfering with the intake point. Okay, so we can say that the standard B can be followed without any problem. Okay, now this is the point that when we use standard A and when we follow standard A and when we follow standard B. All right, this is another photo for the same location. This is the river that we were talking about. Okay, here those are discharge points from other treatment plants. Okay, this is the treatment plant of UTM discharging down here. Okay, and those are discharge points from other treatment plants. All right, so this is standard B, as we said, but those has to be standard A. Those has to be standard A because they came in the upstream just before the intake point, so it has to be standard A. Because if it is standard B, what would happen? Imagine that this standard A is not standard A if it is standard B. So imagine what would happen. Can you just write in the chat? If those standard A are B, the water intake will be contaminated. Right, correct, Christina. The water intake will be contaminated. Why? Because standard B has lower quality of treatment. The BOD is higher, the COD is higher, the suspended solids are higher. All the parameters are quite higher than standard A. So if we follow standard B and after like 1 or 2 kilometers the intake point will take water, so it will be almost polluted and contaminated, and then we need maybe higher treatment, and will cost more money to treat the contaminated wastewater or the contaminated river in order to distribute it to the people. But if from the beginning it follows standard A, so that will be convenient and that will be suitable for intaking the water and distributed to the people or to the areas. Okay, any question for now? I think everything is clear now. When we discharge using standard B, when it is allowed to use standard B, and when it is restricted that we have to follow standard A. Okay, all right. So all of these are standard. Okay. Now we have another regulation for the drinking water quality. For the drinking water. Okay, for drinking water, it means that the water that will be distributed in the pipelines, means in the water lines. Okay, water distribution network. Okay, so this is called drinking water. It's not necessary to be the water that we drink from the water filter or from the mineral water. No, it's not the mineral water. This is the drinking water, means that it is safe if you put it in your mouth, or if you wash your face, or wash your hands, or take a shower. So this all is drinking water. Okay, so this is the basis guideline of treated water quality to be achieved by the water treatment plant operator. Okay, and this standard is prepared by the Ministry of Health based on the World Health Organization standard. Okay, these are the parameters that has to be followed for the drinking water quality standard. For example, we have the total coliform, the Escherichia coli, the fecal streptococci, and turbidity, the color, iron, hardness. Okay, so all of these are parameters. You don't have to memorize the numbers, but at least you have to know the meaning of these parameters. Okay, so try to search for the meaning of those three parameters: total coliform, the E. coli, and the fecal streptococci or streptococci. Okay, so those are parameters related to parasites. Right? Turbidity is something I think most of you has to know. Color, iron, hardness also is the same. So try just to understand briefly what these parameters mean. Okay, and why we concern about them. Why we concern about total coliform. Why we concern about E. coli. Okay, so be aware of the question why. Why we concern about these parameters. Okay, got it? Okay, so try always to know why we concern about these parameters, right? And what are the harmful or the side effects of these parameters if, like for example, the hardness was very high, like 1000, 2000, and if the total coliform became detected, if the E. coli was existed or was detected. Okay, you answer this question by increase your knowledge. Okay, consumption safety, that's correct. The safety in general has to be maintained. Okay, but what is the specific effect of total coliform? What is the specific effect of total coliform, the E. coli, the fecal streptococci? Okay, those kind of things. So try to search for them, try to search and look for an answer. Okay. All right. Now we continue, and oops, yeah, we finished this part of the chapter. Okay. I mean, we finished this part of the chapter. So we will move to another part. Okay. So I will just stop sharing until I open the other part of the chapter. Okay. I will post those slides to the e-learning. Okay. Sorry, my voice is not very well today. I'm having a flu, so I hope I can continue until the end. Okay. Let me see here. Alright. Okay, for chapter number 4, it will discuss. It is one of the interesting chapters, and I believe that all this course is interesting, but you may find some chapters are boring, some chapters are maybe more easy. Okay, but believe me, this is one of the easiest chapters and sorry one of the easiest courses, okay, that you can easily earn grades, okay, high grades, and get high marks. Okay, but it depends. You have to work hard, you have to do the required effort in order to be able to answer questions and in order to be able to succeed. Okay. Okay. So now we start in chapter 4. Chapter 4 talks about the wastewater quantity. Wastewater quantity. So let me share the screen. Share the screen. Okay. So now I'm sharing the screen. Okay, here we're talking about the wastewater quantity. Okay, so as we know, or in the previous chapters, we talk about the wastewater characteristics, the types. Okay, we characterize the wastewater in terms of the quality. Now we want to know some information regarding the quantity. Okay, because in the design process we have to take into consideration both the quality and the quantity, the rates of pollution and also the rates of flow. Okay, how much flow is going to be generated of the wastewater for every day. Okay, so this is very important for us to design the wastewater treatment plants, because for small quantities the treatment plant will be small. For large quantities, of course, the treatment plant will be larger. Okay, so for the water consumption rates, it depends, or it is different from area to area. Okay, it's different from place to place, it's different from country to country, different from a city to a city. Okay, but normally there is a range. Okay, there is a range for the cities that have more than 10,000 persons. The water consumption rate is around 230 to 320 liters per person per day. You might say, how come one person consumes 230 liters? No, that includes everything. Includes even washing dishes, showers, if you wash your car at home, huh? if you water the plants at home, every water activities done at home, it will be calculated, it will be considered. Some houses might consume like 60 liter, 100 liter, and some houses might consume 300, maybe 400 liters, okay, per person. Yes, okay, those who have like a jacuzzi or have a swimming pool at home, okay, so that will be higher consumption rates of water, okay. This is in the city. In the suburban areas, okay, the consumption is lower, and that's normal because the lifestyle is different between the city and the suburban, okay. uh, for your information, for the city, it includes also the offices, everything, okay. In the suburban, there is no so much activities. There is no it's not highly populated, so the water consumption is lower. For heavy industries, it's 45,000 liter per hectare per day. It's calculated per hectare, okay. For light industries, it's 22,000 liter per hectare per day. But why we are concerned about the water consumption? Where is the wastewater consumption? Why we are concerned about the water consumption? Okay? Simply because water will be converted to wastewater. So if we know the water consumption, we can estimate the wastewater consumption. Okay? So the first thing is the water consumption. After that, we can estimate the wastewater consumption. Alright? Okay. And regarding the water demand is categorized into four categories, four types of water demand we have. We have the domestic water demand, houses, schools, maybe universities, something like that. Okay. Public use is like in the parks, okay, maybe the open areas, any kind of public use, open use. Fire demand, those the fire hydrants that in the street, we calculate special water demand for it, okay. And we have the commercial and industrial usage in the shopping malls, in the factories, restaurants, okay, those are all considered as commercial. So this is the four types of water demand. The water demand is different from place to place, from type to type, okay. For the domestic, is not the same as public use, not the same as commercial and industrial. For each area there is a different demand. So the more demand, the more wastewater production, except for the fire demand. It's not considered as wastewater production, but for the others, okay, the more demand, the more wastewater production, okay. So wastewater quantities varies hourly, daily, and weekly. So in the same day, in the early morning, it's different than in the midday, it's different than in the evening. The wastewater quantities also will be different in the midnight, okay. So in the midnight, the wastewater quantities or generation is very low because most of the people are sleeping, there's no such activities, okay. But in the morning at 7 o'clock, all people are wake up and they go to wash their hands, prepare the breakfast, maybe take shower, and all people are preparing themselves to go to the work, to the school, okay. So the quantity of wastewater generation will be much higher, will be maybe in the peak, okay. That's what we call the peak flow occurs at maximum flow for the day. Okay, so this is what we call the peak flow. It is the maximum flow during the day. At what time? Is it at 7 a.m. or maybe at 5 a.m., at 6 a.m., 5 p.m., 6 p.m. Also, we have another peak. People go back to home, okay? Go back to their houses and take their dinner and take showers and maybe go to the shopping mall. So all of these activities will consume water, okay? Will increase the water consumption, right? So we have some definitions. What is the sewage? What is the sewer? What is the sewage treatment plant? What is the sewerage system? Okay, sewage is any liquid discharged from the domestic sources, normally from domestic sources. Okay, from the industrial we call it wastewater. From the domestic we call it sewage, but it's okay. If you call all sewage, it's also okay. Okay, sewer is the pipelines, is the pipes that carry or convey the sewage and the effluents. Okay, the underground pipes. Sewage treatment plant, those plants that are designed to treat the sewage. Okay, and the sewage system is all the system together, starting from the collection point until the discharge point. Collection point then goes to the treatment plant, then goes to the discharge. This is all called sewerage system. Okay, now let's move to something called population equivalent. Okay, but before I start in this in this term, if you have any question or if you have anything not clear, just raise your hand. If everything is okay, just raise your thumb. Okay, I can see that you will be experts in wastewater. Okay, that's fine. That's very nice. Okay, all right. So we will have a break for how long? Let me see. Till now. Okay, we'll have a break for 10 minutes. Okay, for 10 minutes. We'll have a break for 10 minutes. Then we come back again. Okay, all right. So I will turn off my camera and my mic, but we will come back after 10 minutes starting from now. So let's continue in chapter number 4. Chapter 4, as we said, is talking about the quantities. Right? It's very important to estimate the quantities. The quantities that is going to be generated for the wastewater treatment plant. Alright, so let me share the screen. Okay, now there is something we call the population equivalent. Okay, now do you remember in chemistry when we have a solution that contains so many components, I mean so many elements? Okay, we have sodium, we have calcium, we have magnesium, we have nitrogen, we have phosphorus. Can we just add them together like this? We can say like okay, 10 milligram magnesium plus 10 milligram calcium plus 10 milligram potassium, so we have 30 milligram concentration. Can we do like this? Of course not. Of course not. We cannot do like this because you cannot count or add together apples to bananas to oranges and then you say like we have 30 pieces. 30 pieces of what? Okay, so the same goes here. The same also is applied for the what we call population equivalent. It is same as the molar weight. Okay, you remember that in chemistry we convert every element into its smaller weight, then we add them together, then we can add them together. Okay, so here we have something called the population equivalent. It means that for hospital For hospital, the hospital use water. How much equivalent to population as population? Okay. For a hotel, the hotel will consume water, but it's different than the hospital. So how much it is can be converted to population? Okay. For the residential areas, how much it can be for each house? It is equivalent to how many people? Okay. So it's like this. That is simply okay. So the definition says the equivalent in terms of fixed population of a varying or transient population, okay, or other activity. So it is the equivalent, it is what is equal to, okay, in terms of fixed population. Fixed population means that a number of people are living in that place. It's like okay, in the house, okay, so the average number of people at every house is around 5, okay, 5 person, right? In the hotel it's different because we have rooms, so for each room how many people we don't know, okay, so that's why we have to convert it to something fixed, to something a fixed number, constant number, okay. For each room, how much should I count? 2 people, 3 people, 4 people, okay. It depends. It depends on the water consumption, not on the number that this hotel can, the capacity of the hotel. No, it depends on the water consumption, because at hotel we have swimming pools, we have jacuzzis, we have maybe water theme parks, okay, what playground that have a lot of water activities. So all of this will be loaded on the people, okay, whether the hotel capacity is 100 people or it's 1000, okay, the water consumption is not counted by people attending. Same at hospital. At hospital we have beds. We have beds for one hospital. Can it capacity is like 100 beds, 200 beds, 500 beds, okay. How many beds? For each bed there is drinking water, there is bathrooms, there is showers, cooking, cleaning, so many things need water, okay. So all of this is counted on the number of beds, okay. So let us say now here, let's see now here for each premise and activity how we will convert the to population equivalent. Where is this place? Okay, never mind. We just want to know that for each unit, for each housing unit, okay, whether it is a house or apartment, is same, okay. We have 5 PE per unit. So if we have 100 house, how much PE we have? It will be 5 times 100, which is 500 PE, okay. Later on we will use this number to design and to estimate the quantity of wastewater generated, okay. So that is the purpose why we convert to PE. All right. So for the houses, each house is counted as 5 PE. For the commercial or for the shopping malls, okay, is counted in per area, okay, per 100 meters square of floor area, Now that means if the shopping mall is one floor with 1000 meters square, so that means for each 100 square is 3. So for 1000 is 30. So for this shopping mall is 30. If this shopping mall has 3 stories with the same area, okay, 3 levels, 3 stories with the same area, so that will be times 3. 30 times 3 will be 90. Okay, so in that way we can estimate this shopping mall equivalent to how many people using water as a fixed population. Okay, understand? Any question? Please write in the chat. Because I'm sharing the screen now. So I cannot focus with everyone. Just write in the chat if you have any question. Okay, don't hesitate. Okay, we continue. Now for the school, if it is a day school, okay, So the usage will be like from 7 to 1 p.m., right? It's something like that. 2 p.m. maximum. So that means we calculate per student how much or how many PE per student is 0.2. If this school contains 500 students, so that will be 500 times 0.2. Okay, if this school have 700, have 400, it depends on the number of students. Okay, we times by 2. If it is a residential school, so each student is counted as 1 PE, because they are using the water all over the day, just like any residential area. Okay, so that it will be counted as 1. Okay. For hospitals, it depends on the number of beds. For each bed, it is counted as 4 PE. Okay, we have a question. Sabrina says, what if the water supply to them didn't meet their expected demand? So where does the water go, or where they have a tank or store it? Yeah, this is something different, because it means that there is an excess supply. Okay, there's an excess supply. Yeah, of course it will be stored into tanks, and that also will be calculated, that also will be considered. But at the end, we don't look at the actual consumption amount, at the actual consumed water. We look at the type of this premise. Like as I said, for a school, we look at the number of students. Is it day school or residential school? For example, if it is a residential school, for one student to be counted as 1 PE. So if this school has 500 students, okay, so it will be 500 PE. 500 PE. If we have 3 schools like this, so 500 times 3, so it is 1500 PE. Later on, we will use this number to design the wastewater, or to estimate the wastewater generated amount. Okay, I hope I answered your question. All right. Where were we? Okay. 4 PE per bed for the hospital. Okay. So if the hospital has 100 bed, so the PE of the hospital is 400. Okay. All right. So we times for each bed is 4. Okay. Now for the hotels. For hotels is 4 PE per room, not per bed, of course, it's per room. Okay, it's per room. So if the hotel has like 200 rooms, okay, so it will be 200 times 4. 100 rooms, 100 times 4, and so on. Okay, and after that we can add together. Okay, hotels, hospitals, residential areas, houses, schools, universities, offices. Yeah, in that way we can add all the PEs together, and we come out with one total PE for the whole city. All right, for the whole city. Okay, for factories, it is counted per staff. How many staff is in the factory? So we have 0.3 per one staff. Whether he is a worker or a manager, or it doesn't matter. Okay, it's only per staff. 0.3. Whether the factory is large area or small area, it doesn't matter. It depends on the staff. How many staff? Okay, for the masjid or for the mosque, it is 0.5 per person. Okay, 0.5 per person. For the other temples and other place of worship, okay, it's counted as 0.2 PE per person. Okay, 0.2 PE per person. All right, and this table shows you the whole type of establishment or premise and the whole population equivalent. Take a screenshot. We might need it at the end of the class. we may solve a question. So take a screenshot and save it, because you don't have the notes until now. All right, this is the first part of the table. And the second part of the table is over here. Okay, so it shows each premise or each establishment what is the equivalent PE, what is the population equivalent that is used to calculate or to estimate the generated amount of wastewater. Okay, all right. Now, as I said in the beginning of the class, that during the day the water demand is different, and that makes also the wastewater generation also different from time to time. Okay, from day to day also different. In the weekend it's not the same as in the working days. Okay, for countries which have 4 seasons, in the summer is different than the winter. Okay, something like that. Yeah. Okay, so that's what we call the pattern. Okay, for universities, same as schools. I'm not so sure. Okay, so please search for it and bring us the answer. Okay, search for the PE in universities and bring us the answer, because I personally didn't deal with university, but as you have asked, Farah, as you already asked, so search for it and bring us the answer. Not now, later on. Search for it and just send on the group, in the WhatsApp group, that for universities the estimated PE is like this. Okay, I just put the number. All right. So for flow rate, as we can see here, now this is at 12 midnight here at the beginning or at the left side of the pattern. Okay, this is at midnight. You can see during the night the water generation is dropping down because all people are sleeping. Okay, there's no activities, there's no water consumption. Once it is 6 a.m., okay, it will increase sharply from 6 to 7 a.m. increase sharply and will increase to the peak, like at 7 or 7:30 at the peak. Okay, or maybe at 8 a.m. from 7 to 8, normally the peak. So this is the peak flow rate of wastewater. Okay, and it's normal because everyone is waking up and preparing himself, so we generate wastewater. Okay, from kitchens, from toilets, from all water activities. And during the day the water consumption will be high and low. Okay, it depends on the water consumption during the day in the universities, in the offices, in the shopping malls, but normally after 10 it will drop down. Okay, after 8 p.m. it will start to drop down. Okay, start to drop down until it reach 12 a.m. okay, and then the same cycle will continue. Okay, from that pattern we can see the Q average. Q is the flow. Okay, so we can see the Q average. So the average value, it's not the P, we have the peak value and we have the average value. So both values are important in the design process. Okay, so we look into two values. We have the Q average and we have the Q peak. We have the Q average, we have the Q peak. Okay, so let me just write it here. Here we have Q average. Okay, and here we have Q peak. Okay, so we have the two important values, Q average and we have Q peak. All right, So let's continue. So the pattern varies hourly, daily, and weekly. Okay, and also maybe monthly. And a peak flow occurs at maximum flow for the day, and that's what we have said just now. Okay, now what is the design flow rate? Is it the peak value or the average value, and why? What do you think? When we estimate the flow rates, when we make a design of the wastewater treatment plants, the sewer lines, should we consider the peak or the average? I expect that all of you will say the peak, and that's right, but not always. Okay, the normal value is not the peak, is the average. Okay, normally we use the average, but for some units we use the peak, or for some calculations we use the peak. Okay, how? Okay, I will tell you how. Now, why we use the average? First, using the average is more economical for the design process. Why? Because for the peak, it comes like once, or in 1 hour or 2 hours, okay? Or it comes maybe in 1 day or 2 days during the week, or it comes in 1 month. So we don't follow the week all the time, and we don't follow the peak all the times, okay? Because most of the time we are following only the average. One might say that, okay, the peak, if we reach the peak and we are not ready, we may have some failure in the system. That can be, but normally we use the average and we make some safety, or we increase a little bit, so that will be also enough for the peak. So don't worry, okay? And the peak is not constant. It's not something like every day it should happen. Yeah, it will happen, but it's also different from day to day. So the average is normally the governing, or the datum that we, or the reference that we use for our design. But normally for design flow rate, okay, for design flow rate, normally we use the number like 225 liters per capita per day. Liters per capita. Capita is a person, okay, so liters per person per day. Okay, whether it is a residential or commercial or whatever, this is an average. This is an average flow rate. It's not the PE. It's not the PE. Later on, or now, we will calculate the total PE. We have to calculate the total PE, then multiply by the design flow rate. Okay, because total PE represents capita, represent how many population equivalent. Okay, and this one represent how many liters per equivalent per day, per capita per day. Okay, so when we multiply together, we will get how many liters per day. Now we will see. So the average daily flow. So as I said, we have the two values. We have the average and we have the peak. Okay, sometimes we use the peak, but normally we use the average. All right. So we have the average daily flow equals the design flow rate, which is 225. Okay, let me write it here. This is okay, so the average flow rate is 225, okay, times the PE. Okay, so design flow rate is 225. 225 liter per capita per day. We multiply by PE, so the answer will be in liter per day. Okay, liter per day. Then, in order to calculate the peak flow rate, the peak flow, okay, we have something called the peak flow factor. Peak flow factor. Okay, this factor will convert the average to the peak. All right, so we have three main equations. We have the average daily flow, we have the peak flow factor PFF, and then we have the peak flow rate. The average daily flow is the design flow rate times the PE. Okay, the peak flow rate is the 4.7 times PE in thousands. Like for example, if I have 10,000 PE totally, okay, so I will substitute for the P here as 10, not 10,000, 10. If the total PE is 6,500, okay, so I will substitute as 6.5. Understand? Okay, so the P is in thousands. P in thousands. Okay, to the power 0.11 or minus 0.11. Okay, and then finally we have the peak flow rate, which is the average, which is the peak flow. It is the PFF times average daily flow. Alright, PFF times average daily flow. That will give you the peak flow rate as also liter per day. Okay, liter per day. Okay, so these are the main calculation related to the estimation of estimation of wastewater quantities. Okay, all right, so let's continue. Any question until now? PFF has no unit. Yes, PFF is unitless because it's only a factor. It's only a factor, okay, that has no units. Okay, so everything is okay. All right. So let's have an example, a simple example. Okay, now we have a new residential area. It consists of the following premises. We have a residential house, which is 3,200 units. We have a commercial building that is 10,000 meters square. We have a primary school that is a day school, okay, which is 800 students. And also we have a private hospital that has 120 beds. Okay, so calculate the average daily flow of sewage and the peak flow rate from the residential area. Now, if we want to calculate the average daily flow, first of all, we have to know what? We have to know what? PE, right? We have to find the PE, correct? So first we have to find the PE. So how much the PE for each of for all of these? We calculate the PE for each unit or for each area, then we add them together to get the total. All right. So here it is. Determine the total PE first. Okay. For each premise, for example, for the residential area, we have 3,200. So for each unit is 5. So the total for the residential houses is 3,200 times 5, which is 16,000. Okay, 16,000. Now for the commercial building, 10,000 meters square. So 10,000 meters square times 0.03, because each 100 square is 3. Okay, so we times 3 over 100, which is 0.03. So the final answer is 300. Okay, for the primary school, 800 students, and this is a day school, so 800 times 0.2, so the PE is 160. Okay, for the private hospital, 120 beds, so the PE is 480, and finally we have the total. Just add them together, So the total PE is 1000 or 16,940. Okay, now we have the total PE. Okay, after that we can calculate the average daily flow. The average daily flow simply equals the PE times the standard flow rate, or the average flow rate, or the standard flow rate per person. Standard flow rate or standard wastewater generation per person, which is the 225. So the total PE times 225 equals this number, 3811.5 meter cubic per day. Okay, of course we convert to meter cubic per day. This will be liter per day. You have to convert it to meter cubic per day, just divided by 1000. Okay, then after that we find the peak flow factor. The peak flow factor, PFF, 4.7 times PE, but in thousands. The PE is 16,000, so it is 16.940, all to the power 0. Or minus 0.11. Okay, so the final answer is 3.445. This is for PE. Okay, now for the peak flow rate, just multiply the PE times average daily flow. It will give you the answer of peak flow rate. Okay, so that is simply the peak flow rate. That is the average daily flow over here. Okay, and here is the peak flow factor. Okay, fine. Any question? Okay, then if everything is okay, we can just move on and see what is next. Oops, okay, we have finished the chapter. Oh, that's very fast. Okay, since it's very fast, so we want to use some time. Just have a look, just make sure that everybody is awake. Okay, so all of you are here, but some of you maybe were okay. All right, so this is the end of the chapter. If you have any question, just let me know. I was thinking that if we can have just a quick question, okay, can solve it together. Do you have calculators available? Okay, good. All right, so for those who have calculators, you can work out this question I will share now. It's a question that has been in a final exam, I think. Yeah, this question is from one of the final or previous final exams. So I will share now. Where it is, okay. All right. So this is a final exam question. We have a development is to be constructed in an area of about 88 hectares. Okay, 88 hectares. This is the total area of the development. Now, the following premises are to be built in that respective area. We have Taman Sentosa. Okay, so we have 150 units double story, we have 100 unit single story, we have 90 units semi-detached stories. Okay, we have Econ GMAT Mall with 35 shops outlets in one building. This is the length and width of the area. Okay, the sports complex, okay, maximum to accommodate 70 people at one time. Okay, so this is 0.3 hectares. MRSM Senibong, okay, how many students and teachers, 1.5 hectares. Self laundry center, we have 5 unit washing machine, 3 units dryer. Okay, so it is 1 or 11 meter length, 20 meter width. Okay, we have Masjid Tamal Sentosa, maximum to accommodate 1000 people, and this is 0.3 hectare. Alright, so for this question you have to calculate the average daily flow and peak flow in meter cubic per day. Okay, if you understand the chapter or the class for today, so you will be able to solve this without any problem. Okay, and you can start now. I will give you like 10 to 15 minutes. Work out the question, and then we come back again. Okay, I will keep this screen sharing, but I might turn off the microphone. Okay, and okay, so please take your time to solve the question. If you have any comment or you have any notes, put it in the chat. Okay, just put it in the chat, so I will be following up with you now. So start now, take 10 to 15 minutes. You can unmute your microphone if you want, just in case you need to share something or to discuss something. You can unmute. It's okay. About the mole, the area means the area of the whole one, yeah, it is for one shop outlet, 150 meter times the mall, 150 meter. No, this is not one shop outlet, this is the whole mall. This is all the mall, okay? This is all 150 meter times 100. This is the area, the total area, okay? Total area of mall. Oh, you have got the total. Okay, we will see the answer together after a while, so don't worry. Just keep it. Okay. Okay, are you done? Dryer unit included in the machine for the self-laundry center. You have to answer this one. You have to know, do we include dryers or do we include only the washing machines? Now think about it. Which one use the water? Is it dryers or also washing machine, or is it washing machines including dryers or no? Because in the self laundry we know that we have dryers and we have washing machines, so which one use water? You have to include it. This is a trick. This is the trick that many students that oh I mute, oh sorry. Okay. So regarding the washing machine, you have to you have so for the self laundry center there is a trick. You have 5 units washing machine and you have 3 units dryer. Okay, so which one use water? Is it washing machine or dryer or both? Okay, washing machine, of course. The dryer using, does it use water? It doesn't use water. So this is a trick. Many students came and say, okay, 5 plus 3, so we have 8 units. Okay, and they became to calculate like this. No. Okay, so please be careful. Be careful. Okay, we used to put some tricks in the exam, so that's our job. Yeah, that's our job. Okay, I think all of you are done, so let's have a look on the answer. We give you another 2 minutes. 2 minutes, 1 minute more. Okay, 1 minute more. For double story and single story, can we calculate it with the same term as a house? We calculate the house, as a unit. Okay, we have to calculate the house as it is, as one unit. If the house is divided between 2 separate stories, like let me say this, or some kind of house is divided between 2, like if you rent or if you buy, you will buy only the only 1 story. It's not 1 unit, so that will be considered as 2 units. But normally, 1 house, 1 unit, whether it's 1 story or double story, that's 1 unit. Okay, so let's see the answers. So give me 1 minute. I see where is the answer. So first of all, we have the PE for Taman Sentosa, 150 plus 100 plus 90, and all will be times 5, so that will be 1,700. 1,700. Okay, so this is for the Taman Sentosa. Sorry. Then we go to the Econ Mall. It's a shopping mall, so 150 times 100 or times 3 over 100. We are concerned about only the area, okay, the total area. It doesn't matter how many shop outlets inside there, Okay, so it will be 450. All right, the sports complex, okay, 70 times 0.5. You have in the table something for the sports complex, so it will be 0.5 according to what? According to the number of people, not according to the area. Okay, so according to the number of people, it will be 70. All right. For the school, it's the number of students times 1. This is times 1 because this is a residential school. Okay, so it is 1275. Okay, for the laundry is 5 times 10, so only the washing machine is considered. Only the washing machine is considered. It's 5 times 10. Okay, and for the masjid or the mosque is 1000 times 0.5, and this is 500. Okay, total PE, just add them together, so the total PE is 4010. Why we use 0.5 for sports complex? Go back to the table. You already post the photo of the table on the WhatsApp, so go back to the table. You will find something related to sports complex, and the PE is 0.5 per person. Okay. Okay, then we go to Q average. Q average is the standard flow rate, okay, which is 225 liter per capita per day, but this is in meter cubic per capita per day. Never mind. Okay, times the PE, so the Q average is 902.25. Okay, PFF 4.7 times PE in thousands, so the PE is divided by 1000, all to the power minus 0.11, so the PFF is 4.034. And then we go to the Q peak, is the P, or the Q peak is the Q average times PFF. That gives us the answer, which is 3639.8 meter cubic per day. Okay, understand? So this is the answer. These are the answers. You can take a screenshot. Okay, you can take a screenshot if you want. Okay, don't worry about it. This is only the breakdown of the marks. Normally we don't show it, but here, because this is an answer scheme, so you have seen it, but it's different from exam to exam. It doesn't matter that it will be same for if we put another question like this in the exam. Okay, but it's only a breakdown of the points. So okay, so this is the answer. You can just take a screenshot and save it to yourself. Alright, so now we have done with the class, and if you have any question, let me know in the chat, or if you don't have and you have it later, so just send on the WhatsApp. Okay, and I appreciate everyone's attendance, and thank you so much for attending the class, and hope everyone will be always safe and in good health. So for now, take care, and we see you later. Okay, so for test 1 it will cover until this topic, right? For test 1 it will cover until this topic. Okay, until today's class, test 1 is covering. After that is related to other tests. Okay, for test 1 it's covering until the end of this class. Until the end of this class, test 1 covers until this topic. Okay, this one covers until this topic. All right, any question? Everything is okay? Raise your thumb. Okay guys, thank you so much, and we meet up on our next class. We hope all of you will be in always safe, so take care. Assalamu alaikum wa rahmatullahi wa barakatuh, and see you. Jumpa lagi.
Lagi sir. Thank you sir.
Okay, bye. Take care.
Thank you sir.